Okay, we're doing worksheet 78 and we're talking about composite figures today. We are starting with the review. We are finding the area of each figure and we are rounding to the nearest tenth. So make sure you pay attention for that. So the first one we determined was a parallelogram, and the area of a parallelogram we have on our little sheet, and it is base times height. Okay, well the good news is I know the base. And so when area is base times height, the base is 7.6 and the height is the 3. Now it's a little hard on this copy. You can see that this is not a solid line. This is not part of the figure. It's just to show you the height. So I don't want the slant height. I want the height, which is an altitude, 90 degrees. So we throw that in the calculator into the nearest tenth. What do we get? I have it as 22.8. Do you agree with that? And what would you label it? Yards squared, because we found area. Okay, let's move over to our rectangle. Rectangle is really the same formula, base times height. So base times height, that would be 5 times 9, and so my area is 45 inches squared. All right, what's my next shape in number 3? That is a square because all 4 sides are congruent. We got 4 congruent angles. So the area of the square is also base times height, or just a side squared, because 10.8 times 10.8. So you can look at it either way. You can write 10.8 times 10.8 or 10.8 squared. All right, nearest tenth. I have 116 point what? 0.6, do we agree? Okay. All right, next figure, we got to be careful with this. It is a triangle, and again, because of the copy, it's not as easy to see. This is the triangle we're talking about right here. Okay, that's the triangle I am talking about. This is supposed to look like a dashed line. It's just to show you the height or the altitude. So this would be that the area equals 1/2 base times height. So that'd be 1/2 a base of 4. And what would be my height? The 4.8. So we're really not using the 9 for anything. I gotta be better about showing my work on the screen. All right, nearest tenth. I have 9 point. This is where you guys use your calculators and you shout out the answers. 9.6 yards squared. Nothing like the sound of opening calculators in the morning, huh, Mr. Adams?
I know, it's just like fun.
It's amazing. It's amazing. Now there's the sound of dropping calculators. That's not a good sound. All right, what is number 5? That is a trapezoid. That formula is a little more complex because we don't have one base, we have 2 bases. So it is half the height and then bases added together. We have to be careful with our formulas. I rearranged it because I want to make sure you guys saw when you do half the base plus base, it's because you're taking the average base, but we'll just use this original one now. So in my trapezoid, the area is 1/2 the height and then B1 plus B2. And the big thing is you use parentheses and you do add these. So your calculator knows to add them and then multiply. So it's 1/2, what's my height? That 90 degrees, so 6 feet, times base 1, 12, plus base 2, 6. All right, so what's my area equal? You can type the whole thing in the calculator. You know, this is 18, half of 6 is 3, 3 times 18. I think it should be 54 feet squared. All right, we got another triangle. Now, this triangle is the whole big part, okay? So the altitude, because it's an acute triangle, the altitude is inside. This was an obtuse triangle where you have one angle greater than 90, so the altitude has to drop from the outside to hit 90 degrees. So area is 1/2 base times height. So what's the base of this triangle? Because everything's labeled. What's the base? The base is 9, and I know that's the base because it's with the 90-degree altitude. So if I had an altitude from here to here, then you would say 7 was the base. All right, so 9 times the height, which is 6. All right, so what do we get for my area? It is 27 centimeters squared. All right, next two are circles. So, and if you guys didn't notice on the bottom of your sheet, you have all these formulas again, but we have our formula sheet too. The only formulas that aren't on your sheet are rectangle and square, because we know those. But if you wanted to add those, you could. All right, in my circle, the area of a circle, not perimeter, the area is pi r squared. So we can use pi today. The radius was given to us as 6.1 squared. So what is the area? So go ahead and use your pi key today, where the other worksheet we could not use our pi key. We had to use 3.14. What are we getting? Yep, I agree with you rounding. 116.9, we label it yards squared. Okay, now in number 10, they didn't give me the radius. What's this called when it goes the whole way across? Diameter. So what is my radius? 5, it's half of that. So when I go to do area, I have to use the radius. So type that in the calculator, and I get 78.5, and we label it kilometers, kilometers, however you want to say it, squared. Okay, so that was just sort of a quick review of our problems. Not so quick, it was 6 minutes. We are talking about composite figures today, so that's what's going in here. A composite figure is made up of simple shapes such as triangles, rectangles, trapezoids, circles. It could be a half circle or a semicircle. The area of the composite figure, we just find the area of the easy shapes, the simple shapes, and then add or subtract it. Okay, so if you look, do you see that I have no idea what this shape would be called? I can tell you how many sides it has and give you a general polygon name, but it's not something specific. So I'm going to break it into shapes that I know. So it says find the area of the shaded region of the figure, if necessary, round to the nearest tenth. So let's keep that going. So do not overwhelm yourself by this. What you want to do is sort of cut it. So if I gave this to you in a piece of paper, you would cut it out. So if I had to cut this one, you could cut going down to make 2 rectangles, or cut going across to make 2 rectangles. It really doesn't matter which way you do this one. So what I want you to see are these 2 shapes. So here's my first rectangle in blue. Okay, what's the area of this rectangle? Well, this is a height of 12 and a width of 15. So the area is 15 times 12. What's the area of that top rectangle? 180 centimeters squared. Now, for some people, they like to write that in here, and that's fine if you can. It doesn't always work. Now, I need to find the area of this rectangle. I know that one side is going to be 27, but I need this height. So 27 times what? How would I get this piece since they didn't give it to me? Well, the whole thing's 21, right? If this is 12, isn't this 12? So to find this piece right here, I would take 21 minus 12, and what do you get? 9. So if this piece is 9, this piece is 12, there's my 21, this piece is 9. It's almost like putting a puzzle together. So we take 27 times 9, and I get 243. And that would be centimeters squared. Okay, so again, I'm writing this in 2 places. You can do what you want with it, but I'm not done yet. To find the overall area, I need to take the area of that top rectangle plus the area of the bottom rectangle. And what do I get for my overall area? I have 423. Does anybody agree with me? Yeah? Fabulous. All right, there we go. Okay, go over to number 10. What do you see there? I mean, it almost looks like half of an arrow. Do you see if we extended, this, we could see like a whole arrow? This is what I'm seeing. I think this is the best way to cut it. Someone wanted to make like a trapezoid out of it because they love trapezoids, but then I'd be stuck because I wouldn't be able to find, some of this information. So I'm cutting it into the easiest figures I can. If you would have come across this way, again, I would have had a little triangle and then I would have had a trapezoid. So I think this is the easiest way. And no matter how you do it, you're going to have a little extra work to do. So here's the rectangle. That's the easy part. Because what's the area of this rectangle? 22.5 times 37.5. So what's the area of my rectangle? Of 843.75. No, yeah. Do you agree with that? All right, now I know it says nearest tenth, but I'm not done yet, so I'm keeping those two decimal places. Here's the problem. I can't find the area of this rectangle. There's a couple things I need from it. I know this, and guys, if we cut this going down, do you see that we did make a right triangle? If this is a rectangle, that's 90, that's 90. So I do have a right triangle. The problem is, if I'm using this as my height, and this is my base, I'm stuck. I actually don't know my height, and I actually don't know my base. Do you see that issue? So what would be the base of my triangle? Well, if this whole thing is 75, when I take off the 37.5, so this piece right here is 75 minus 37.5. And what do you get? You actually should get 37.5. It actually is half of it. Now, we don't know that. We can't guess that. We can't look at it and think it's half. Like, we have to do the math. I still don't know the height, guys. So what do you want to do? What? Well, I can't multiply anything yet. I would use Pythagorean Theorem. Isn't this a right triangle? Now, someone was working with me yesterday and we realized there were a whole bunch of triangle issues because when we were doing Pythagorean Theorem, we were doing the wrong sides, right? So be careful with this. This is my height. So it's going to be h squared plus, so the leg squared plus the leg squared, so plus 37.5 squared equals 62.5 squared. And it is a very common mistake. So I can't stress that enough. You can't just throw these numbers in. The leg and the leg equals the hypotenuse. Now, these are going to be some pretty big numbers in decimals. So here's what I'm going to do. Rather than write this out and write this out, I am going to just go ahead and know that I would have to subtract this number. So I'm just going to subtract it as it sits and let my calculator do the work for me. So here's, do you see, instead of actually writing out what this is squared and this is squared, I'm just going to put it in my calculator. It understands to do the square first. So I'm going to type in 62.5 squared minus 37.5 squared. Are we okay with that? So I'm not adding them because they're not the two legs. I have to take the leg away. And I get h squared equals 2,500. Okay, so how do I find the h value? Square root it. And if you know what the square root of 25 is, that's 5. So this would be a height of 50. Now, just to make sure we see that, square root of 2,500, there's your 50. So we definitely had to do extra work there. Now, all of that work just gave me the height. I still need to find the area of my triangle. And that would be, area of a triangle is 1/2 the base, which is the 37.5. Notice I'm using the yellow, times the height, which is 50. All right, so type that in your calculator. And that is just for the triangle. 900. Yep, I agree with you. So the area of the triangle is 937.5. And that would be meters squared, right? So if you ever wanted to separate this, like I could put the little shape here. So this is saying, hey, area of the rectangle, area of the triangle. That might help some of you, to differentiate which one you did. Now, what we need to do is add these two shapes together. So take the area of the rectangle, 843.75, and add it to the area of the triangle, which was what, 937.5? And what is our overall area? I have it as 1,781.3 if we round to the nearest tenth. Does anybody agree with that? It was 0.25, but I got 0.3. Yeah. Are we good? Okay. So it wasn't horrible, but it, we did have extra because we had to find the height. So these are like puzzles. And honestly, if you just look at it, it's really hard to do. It's really the idea to help trigger yourself is to label things, okay? So here's this next picture. There are 3 shapes in number 11. Can you pick them out? 3 shapes. They actually sort of helped you out. Do you see the triangle on top? Yes. Now, if they didn't give us these lines in the middle, I don't know that we would have enough information because you couldn't assume. And I do sometimes feel like we are assuming that this is a half circle. There's really nothing that's proving it to us. So you do have to watch for that. So you were right. There it is. And a half circle is the same as saying a semicircle. All right, so I have a problem with all 3 of these figures. I don't have the information on all 3 of them that I need. Like to find the area of the triangle, I would need this is the base and this is the height. To find the area of the rectangle, I have the height, but I don't have the base, or I have the width, I don't have the length. And to find the area of a circle, don't I need the radius, which could come from the what? Diameter. So do you see that these 2 lines are what I need? Do you see that idea? Okay, now I do need this. This one's not bad. If this whole thing is 7.8 and this piece is 3, wouldn't this just be 7.8 minus 3? So this piece is 4.9. So in my triangle, this height is 4.9. What I need is the base. I have to use the triangle to get that. There's not any other information to get it from the rectangle or from the half circle. So I'm going to have to use my triangle. And again, to find this, I'm using the Pythagorean Theorem. So I'm just going to do b squared, or a squared, plus 4.9 squared equals 10.2 squared. So really had to look at that and see what I needed. I'm going to do the same thing. Rather than writing these numbers, well, it's at 4.8. Yeah, that's my mistake. Thanks for catching that. This is 7.8, so it should be 4.8. I don't know where I got the 9 from. Good catch, because everything would have been wrong. So instead of putting these numbers down, I'm just going to go ahead and show that I would be subtracting this. It's going to save us a little bit of writing, but we're still showing it. And I get b squared equals, I'm going to type it in, 10.2 squared, make sure you square each piece, minus 4.8 squared. I get 81. That's nice, right? Why is that nice? Because I have to take the square root. And what's the square root of 81? 9. Okay, I just used up way too much room. But there you go. That's 9. So the area of my triangle is 1/2 the base times the height of 4.8. Remember, I had to fix that. So find the area of the triangle. I have it as 21.6. See if you agree with me. And of course it'd be feet squared, but I'm going to leave that out. Now, find me the area of the rectangle. Wouldn't that be 3 by 9? And you want to show us what you're putting in. I know it's some writing. So the area of my rectangle is 27. And then I need the area of the half circle. Doesn't really look like a half circle. You can maybe do better than me. Okay, now, the area of a circle is pi r squared, right? Actually, let me just write that number in. What's the radius of my circle? Well, this whole thing is 9, right? So wouldn't the radius, can you picture this circle extending, being a whole circle? Can you see that? The diameter is 9, so the radius is 4.5. I still didn't leave myself enough room. 4.5 squared. Okay, now I don't have a whole circle. What do I have? I have a half circle. So I'm really sort of doing half of that. We should get the area of this. I have it as, what do I have? 31.8. Do you agree with that? Now, I think that's already been rounded to the nearest tenth, but 31.8. So what do I have to do with all of my areas? I am now going to, I'm going to put a big plus sign here. I'm now going to add them up. So what is the overall area if we add up all three of these shapes? Do you have it for me? Anybody? See if you agree. I have it as 80.4. It'd be feet squared. Do you have 21.6? 27 and 31.8? Oh, did you not take, you have to take half of the circle. I don't think you did that. Does that make sense? Okay. That, because if I had 31.8 and you had 63, I think that's why. Good catch. See, it's a good thing we looked at that. All right, and number 12, I see an envelope. You know the back of the envelope? Do you see that too? And I'm only looking for the area of the shaded region. Now these, we were adding together three different shapes. This one I actually want to take away. So I don't know how to find this funky little shaded region. Do you see that? But can you guys pick out that we really have a regular rectangle and then a triangle that we want to get rid of? So the area of the rectangle, the full rectangle, is 10 by 5, which is what? 50 inches squared. Okay. What's the area of my triangle? It's 1/2. You said the height is 3. What's the base? Yeah, that's also 10. So this one wasn't so bad. We didn't have a whole bunch of extra work to do, right? Everything was given to us. And the area of this is what? 15 inches squared. Now, I'm not adding these together. It was not like a rectangle with a triangle attached to it. We're trying to take out the triangle. So we would take the area of the rectangle and take away the area of the triangle. So I'm taking 50 minus 15. And what do we get for the area of our odd shape? 35 inches squared. I hope not. What are you over there doing? Math. I know, I needed a stretch. This is a long one, guys. All right, what do you see in 13? You see two circles, right? In a what? A square. Now, here's the thing. We're assuming a little bit of stuff. These are called inscribed circles. It's inscribed because all four touch a side. So if this is a circle, it could only be inscribed in a square because it has to be the same distance across. This right here is the same distance as the base of your square. And this would also be the same distance as the side of your square. Now, if the whole thing is 8 and this piece is 4, wouldn't this piece also be 4? All right. And so we are looking at these as squares. So we're not assuming they're squares. We know they're squares because they inscribed. Here's the deal, guys. I have two circles. I need to find the area of two circles. So I have two circles. So pi times r squared. What is the radius of one of the circles? Well, if this whole thing is 4, isn't the diameter 4? So what's the radius? 2. That's it. That's all I have to do. I have one circle with pi r squared, and I have 2 of those. That's it. This one wasn't bad at all. All right, so type that in your calculator. Round it to the nearest hundredth. I have it as 25 point. Anybody? 25.2. And I labeled it unit squared because they didn't give me a unit. Now, it would have been a little bit more if we would have flipped the shaded region to all that oddball stuff outside of the circles. Then I would have to take the area of the big square, 64, right? 8 times 8, and take away the unshaded things. All right, number 14 looks like almost like a bullseye. Do you see it? what I'm trying to find is the area of that donut. Now I want donuts. Did you guys get donuts with lunch yesterday?
They were actually so good.
That's what someone said. I saw some kid take a bite of it and their face like dropped open. I'm like, okay, I guess they like it. I guess Mardi Gras, Fat Tuesday. Isn't that Fat Tuesday? Isn't that the day? Yeah. All right. Well, I want this donut shape. Do I really care about this big circle? I actually don't need to find the area of the big circle. I'm actually going to ignore that and find the area of this whole circle. Now, if I do this, everything in here, I'm finding the whole circle, including that little guy. Then what I'm going to do is I'm going to take the little guy out. Okay? So find the area of the, I'm going to put B circle for big circle. And that is pi times the radius squared. What's the radius, guys, of the big circle? Well, if from here to here is 3, isn't this also 3? Well, okay, the diameter is 12. Yes. So do you see that idea? From here to here would be a 3, a 6, and a 3. That's 12. I only want from here to here. So this would be 6. That's the radius of the big one. Okay, so what is the area of the big circle? Area of the big circle. 113.1. Okay, I'll take it. You could have also just left it as 36 pi. Now, what's the area of the little circle? Area of small circle. Well, that's going to be pi r squared. Look at that little circle. I'm going to circle that one in yellow because that's what we're going to take away. Isn't the radius 3? Okay, so what's the area of the small circle? I don't have this written down, so you got to help me out. 28.3. Okay, so I don't really care about this big piece, so I didn't need to use the full circle, but I'm going to take the area of the big circle and cut out that little circle. So that would be 113.1 minus 28.3. All right, tell me what you get. I have it as 84.8, but I don't know that we have the same rounding, so what do you get? It is 84.8? Okay. Oh, I guess we'd have to bar. Okay. And I'm just going to say units squared. Okay, let's see what else we can knock out. And then if we need to finish something up tomorrow, we will. And then we'll practice these. All right, what do you see in 15 overall? I see a trapezoid, right? But I don't want the area of the trapezoid. I want the 2 little triangles. The problem is I don't know enough information on the 2 little triangles. That's a problem. Now, the length of the whole base is 9, like here to here. So that means the area of the rectangle was what? 4 by 3. Do you see that? Or, not 4, sorry. Shouldn't that be a 5? That was me being dumb. Now, I would love, bless you. I would love to assume that this is split equally. I don't know that this is called an isosceles trapezoid, so I don't know that these triangles are the same. If so, we can maybe find the area of this saying, hey, if this, did I just screw that up again? Okay, that's a 5. Bless you. Yeah, I wrote 2. I don't even know what I'm making up stuff, but the area of the rectangle inside is 3 by 5. Guys, to find the area of the triangle, I know the height's 3, but I actually don't know what this base is. It could be a 2 and it could be a 2 because wouldn't that add up to 9? But I don't know that. So what I am going to do is I'm going to do the formula of the whole trapezoid, which is 1/2 the height, which is 3, times base 1 plus base 2. So I'm actually going to find the area of a trapezoid. I believe that should be 21. Area of trap should be 21. Does anybody agree with me? 14 times 1.5. Yeah, that would work. Okay. And then I'm going to take away the area of the rectangle. So area of the rectangle is 3 by 5. So the area of the rectangle is 15. So to find the shaded triangles on the outside, I'm going to take the 21 minus 15. So I'm taking the full trapezoid and I'm cutting out that center. And that leaves me with area of 6 units squared. All right, let's see if we can get one more in before you leave me. So again, it's tempting to want to try to find the area of the triangles, but we really can't say what the bases are. All right, this one reminds me a bit of a basketball court because like the 3-point, even though they don't hit completely on the corners. But what I have here is a big rectangle and 2 semicircles. And wouldn't 2 semicircles with the same diameter make one full circle? Okay, so first, I'm going to take away on this one. So let's find the area of the full rectangle. And that would be 33. And even though this is in the middle, that's the height of the rectangle. That's 16. So 33 times 16. All right, so what do we get for that area of the rectangle? 528. Okay. Now, I'm going to put down here area of the circle. You guys get that it's really 2 half circles, right? But why find 2 half circles and add them together? If you can imagine picking this piece up and sliding it over here, we would have a full circle. Now, the area of a circle is pi times r squared. So what's my radius? It's not 16. What is it? It's 8. So be careful with that. All right, so that, I have it like 201.1. Does that sound good? Okay. So I'm not adding these, I'm going to take it away. It's different if it was added onto the sides. So I'm going to take my 528 and take away 201.1. So what is the area of that oddball shaded figure? I have is 326.9 feet squared. Okay. Okay, this is a super long lesson. We're just going to finish this off to have it in one video. If you look at number 17 here, you can see the 2 shapes, very obvious circle. And I don't know how to find the shaded region with just what I have. I know this is a half circle, but I don't know how to find these slivers. So I think the easiest thing would be to find the area of a circle, find the area of the trapezoid, and take it away. So the area of the circle is going to be pi times the radius squared. Now, if the diameter is 20, then the radius is 10. Okay, so we'll throw that in the calculator. The area of the circle, that's my little circle symbol, is 314.2. So I'm just rounding that. And then I need to find the area of the trapezoid, and that's going to take a little more effort. That is 1/2 the height, which is 8, and then base 1 plus base 2. So that's 12, and make sure you use the full 20 for base 2. And so the area of the trapezoid is 128. Now remember, I'm not putting these together. I'm taking the circle and taking away. So take the area of the circle and subtract the area of the trapezoid. So the area of the circle was 314.2. Take away the 128, and we get the final area for this odd shaded region is 186.2 centimeters squared. There you go. All right, last one, hang in there. Number 18, we have this odd, again, colored in shape, and it is 8 by 12, and we have to cut this out. So literally picture cutting out that figure. So we're going to do the area of the big rectangle, and that would be 8 by 12. So the area of the rectangle on its own is 96 inches squared. And then the area of the square. Now, the reason I know this is a square, it's all marked that 4 sides are the same. So they're all 4s. And that would be 4 squared, or 4 times 4. So the area of the square is 16. And that would also be inches squared. Okay, so I'm going to take the area of the full rectangle and take away the area of the little square. And that would be 96 minus 16. And my overall area is 80 inches squared. So nice to end on these two that weren't so hard. So composite figures, you could be taking something away if it's not shaded on the inside, or like the first couple that we started with, you could be adding small shapes together.